Well, hi there, everyone, and welcome to Dome at Home. How are you tonight? My name is Scott Young, and I am the Planetarium Astronomer at the Manitoba Museum and the host of Dome at Home. Thank you for joining us. We've got lots of folks joining us in our Zoom webinar. You can register in advance, and that way you get in on the chat and stuff like that. We've got a big chat going, as well as some community stuff, as well as, of course, you can ask questions that way. We're also streaming out live to Facebook and YouTube, the Manitoba Museum's various pages out there. So you might be watching us there, so welcome. We are going to be doing a whole bunch of really cool stuff tonight. We've got our very first guest segment. We've got local teacher Megan Waters, who's going to be telling us about some of the stuff she's been doing in her class using astronomy. We're going to be looking at some of the winter constellations. We've got, I don't know if anybody saw the moon this evening, just as it was rising. Wow, spectacular. We're going to be talking about the moon and why it gets so high right now, and a whole bunch of other things as well. You know, all the whole universe, basically, we're going to cover. With me, as always, is Mike, floating there in the background. Mike, how you doing?
Scott, how are you doing tonight?
You know, pretty good. I've been running in and out to try and catch some of the clear skies, and I haven't bothered, you know, bundling all up. So I just sort of run outside for a few seconds and look around at the sky, look at the moon and stuff like that, and then run back in. So it's been a little chilly, but you know, it is what it is.
I agree. I was out last night myself, and yeah, cold weather, but I took a few moments to look up and look at that beautiful full moon and some great constellations out too. I'm so excited for this show, and I'm excited for people to learn about the things they can see now that it's going to warm up a little bit.
Yeah, the January can bring really, really great skies for stargazing. You get nice long nights when you get a big high pressure ridge that comes in like this and makes it really, really cold. The sky is pristine. So if you can survive, you get really good views. But personally, I like to wait for that thaw myself. I haven't been doing nearly as much as I have tonight. Yeah, hi Kim, the moon is awesome. In fact, I saw it just as it was rising, and it was big and gigantic and sort of pink orange, beautiful to look at. Now it's up higher. It looks more clear white because we're not looking through all of the haze at the low part of the atmosphere along the horizon, but still beautiful to see. All right, let's move along. One of the other things that we're doing here is we get a lot of mail from our viewers. Lots of folks have been sending us emails or messages or things like that. And a few people have started taking pictures of the sky and sharing those with us. So I think it's really cool, actually, that, you know, people are doing some of the things we're talking about and then, you know, letting us know that, hey, it's working. So we're going to take a look at some photos that you have sent in as well. Oops. There we go. The great thing about this show, we sort of model it on one of my heroes, Dr. Helen Sawyer Hogg, whose book is called The Stars Belong to Everyone. It wasn't just her creed. She actually wrote a book called that. And she really was one of the leaders in Canadian science communication and popularization. So she really is the sort of driving inspiration behind this kind of show. And so I always like to take a moment just to acknowledge her. I never got to meet her, unfortunately, but I do have her book. You might have seen in the cold weather these sundogs and things like that. This is an image from local photographer Gary Stewart. He snapped 4 or 5 shots just of the sun rising right around, I think it was the 24th or so, just when the deep freeze started. And he wanted to know what was going on here. A lot of people reported the sundogs. These are the best images that were sent to us. But you've got the sun right in the middle there. And then you've got on either side these sort of sun-like, almost rainbow-shaped things with like a very bright sun in the middle. They can appear almost as bright as the real sun, so it's kind of hard to tell which one is which. So these are called sundogs. They happen when it's really, really cold. And basically, okay, this is a bit of a complicated diagram, but basically there's ice in the air, ice crystals. And the ice crystals kind of look, oops, like these ones here. They're kind of big hexagon plates made of ice. These only form when it's really, really cold and when the air is pretty still. So not when it's too windy or things like that. And as these things are in the atmosphere, they're kind of floating around like this, like feathers. So they kind of, they're not oriented all over the place. They actually all kind of line up with each other. And they act like prisms. So kind of like, you know, when a rainbow happens, the sunlight goes through the raindrops from a rainstorm, gets split up into the colors of light, bent around and so on, and you get a rainbow. Well, these crystals don't do sort of a symmetric job of splitting up the light. They really put it into a couple of different spots. And so because of this very unique shape of the crystals, you wind up with sundogs just to the left and just to the right of the sun. They have been visible a number of days over the last little while, usually when the sun is fairly low in the sky. So, you know, in the morning or in the evening. Sometimes you see more of the rainbow. Sometimes you can also see what we see here, a sun pillar. This is basically light reflecting off the top and bottom of those ice crystals and also sort of making a little bit of a halo in the sky there. So you get these beautiful atmospheric things just because of the cold weather. So yeah, that's one of the silver linings of cold weather. Yeah, let's go with that. If you want to send us pictures, space@ManitobaMuseum.Ca is our email address, and you can always just tag us in the on social media as well if you have pictures that you'd like us to share on the show, or if you have questions about, hey, what's that thing I took a picture of? We're glad to help you out with that. All right. Let us move on. One of the things that we've talked a little bit about here is the seasons, and we've talked about the moon in the last little while. Last week we talked about the moon going through sort of its first quarter phase. This week the moon is almost full tonight. In fact, it looks so close to full you probably won't even notice. It's technically full tomorrow, but you know, we're talking a few tenths of a % difference. We got a lot of questions in our last survey from last week about why is the moon so high in the sky right now? So I thought I'd spend just a minute or so talking about that before we get into our constellations and other things like that. So as you know, we live on a planet, the Earth. It is round. Yes, it is. It goes around the sun once a year, and the Earth is tilted compared to the orbit. So instead of going around the sun with its north pole sticking straight up, it actually is tilted and it goes around sort of like that. So in the diagram here, we've got an image of, here we are on the winter side, and the north pole of the north hemisphere is tilted away from the sun. That's why we're having winter. And on the other side, 6 months later in summer, the north hemisphere is actually tilted a little bit more towards the sun. Okay, so that's what causes seasons. And I mean, it can be, it's a complicated thing, but we're not going to talk too much about the seasons now. If we sort of go to looking at the moon goes around the Earth. And the moon, as it goes around the Earth, we go through the phases and so on. And the moon's orbit and the sun, or the Earth's orbit, are not exactly in line with each other. They're offset by a little bit as well. And so what happens is, let's tilt this around here. The yellow line is basically the plane of our orbit around the sun. And then the blue line is the plane of the moon's orbit around the Earth. And you see they're tilted, and they're tilted relative to the North Pole there. What this basically means, all of this to say, is that when you get the sun being low in the sky because it's winter, the full moon is always opposite. The full moon will be high. And when the sun is high in the sky, the full moon will be low. So for example, in the summertime, the sun gets nice and high in the sky. We get lots of warm weather, but the full moon during the summer just barely goes up above the horizon, stays fairly low. It does not shine right down on us like the moon will tonight. If you go out around midnight, the moon it'll seem like it's almost directly overhead. So at this time of the year, the moon is very, very high just because of the way all of these tilts, sometimes they add up, sometimes they subtract from each other. Sorry, I did a little bit of a dance there. These tilts will either add up or subtract from each other, cancel each other out. Right now, they're sort of all adding up, and the moon is very, very high. So we have our full moon coming up We had a question back here about the wolf moon. So here's the thing. There are names for all the full moons. And allegedly, these are names used by First Nations people. Actually, mostly they're used by the Farmer's Almanac, who I don't think necessarily talk to a lot of First Nations people when coming up with these names, because that's not really what many groups will call the moons. There's all sorts of different names for the moon. Because keeping track of which moon it was, that was basically keeping track of the calendar back in the day before, before we had electronics and that kind of stuff. So many of the First Nations people do in fact have special names for the moon after the winter solstice, the second moon after the winter solstice. The wolf moon supposedly is what this one is called, although there's quite a bit of dispute about that. So I'm not using the wolf moon too much. There are a number of different, the cold winter moon, and there was one, my favorite one of the, I think it was Anishinaabe. The word, I can't pronounce it. I'm sorry, I don't want to do it injustice, but essentially the translation was stay inside. So it was the stay inside full moon, which is pretty much what we have in January. So if you do manage to go outside, bundle up nice and warm, and you can observe the stay inside full moon coming up this week. All right. Bunch of questions. Charity was asking, is the moon very high in the sky in the southern hemisphere right now? So great question. Because of the way the everything works here, if we come back to our image of the tilt, you'll notice that as the northern hemisphere is tilted away from the sun, the southern hemisphere is tilted towards the sun. And so you wind up having the opposite effect. So right now it's winter here in the northern hemisphere, it's summer in the southern hemisphere. Right now we have a very low sun in the sky. In the southern hemisphere, the sun is very high in the sky. And similarly, right now we have a very high full moon in the sky. In the southern hemisphere, the full moon will not be high in the sky. It'll be quite low. So really the whole thing is like a reversal on the other side of the on the southern hemisphere. So the whole thing is all basically flipped around. Okay, let us move along. I know we've got a whole bunch of things, many things to get through tonight, and I want to make sure we save time for questions as we always do. So if you do go observing, and I encourage you to, just make sure you do so safely. It is really cold. Dress really warmly. Don't skip the mitts. Don't skip the boots or whatever. You can get frostbite very quickly, especially if you go out in the snow and you get wet. Make sure you're in a place where you're able to go and warm up and safe. Don't lock yourself out of the house or anything like that. Dress in layers. I tend to wear 3 or 4 different layers. If I'm going to be out for more than about 10 minutes, 3 or 4 layers of clothing and a hat and a scarf and like the whole deal. Astronomy is not an aerobic activity. You're not moving around and doing all sorts of exercise. You're basically standing there under a clear sky, radiating your heat away into space. So make sure you do it nice and warm. Okay, there's one more thing that's happening this this month that I'd like to talk about. We talked a little bit about it last week. The planet Mercury. The planet Mercury is visible in the western sky right after sunset. So you probably, if you went outside now, you will not see it. But if you go outside tomorrow around 6 o'clock, I would say maybe 10 after 6. I'm just getting our system all set up here. If you look off towards the, there we go, towards the west or southwest, just after the sun has gone down, the stars are just starting to come out. There's a quite bright object very low on the horizon. That is the planet Mercury. It's only visible for another 3 or 4 days. So you need to get out now if you want to see it. We're not going to have a good chance to see it again for another 6 months. It's the hardest planet to find of all of the bright naked eye planets. And so you have to sort of take your chance when it comes around, because it's so close to the sun. Most of the time, it's very, very difficult to catch it. Right now, it happens to be just above our horizon in the evening. So if you go out over the next 3 or 4 nights, if you have binoculars, take those along, and that'll sort of help you pick it out of the nice bright twilight, because you really have to start looking really, really early, as soon as the sun goes down. I got a question here from Sawyer. Sawyer wants to know why the sun is so bright in the winter. Well, you know what? The sun is just as bright all the time, but when it's in the winter, it's down lower. And so that means it's shining right in our face. Like if you're in the car, the sunscreens don't get in the way. It's shining right in your face. It comes in your windows and things like that. In the summertime, the sun is just as bright, but it's way up there, and the roof of the car, for example, or your sunscreens or your curtains in your house or whatever will block it out. So it kind of feels brighter, doesn't it? Because of where it is in the sky. Good question. Okay. We are now going to move on to one more segment here before we go to our very first guest. And I'm a little nervous about our very first guest, only because of the technical aspects, because we haven't brought a guest in before, and I really hope it all works. So we're just going to go back to, as we get that set up, we're just going to go back to the evening sky at 7 o'clock right now. So let me just get our sky set up. This program that I'm using here is called Stellarium. It's a free piece of software. You can download it yourself on, I think it runs on Mac and PC, and probably on Linux too. And yeah, you can basically have your own little desktop planetarium. Let's, oops, there we go. Let's look at the northern sky. We always like to sort of remind people where the Big Dipper is. When we started the show at the beginning of January, the Big Dipper was right down at the bottom of the horizon. Now, you know, here we are a month later, and the Big Dipper is sort of moved up higher in the sky. These 2 pointer stars in the Big Dipper always point to the North Star right there. And so that helps you find your directions. If you're in the city, that's probably all you're going to see. But from a darker location, you can see some of these fainter stars. You can see some of the, maybe the stars of Draco the dragon here. This is Draco. Looks more like a snake than a dragon, but whatever. Off in the west, we're still seeing the Cygnus the Swan here. Very low in the west. And one of the heroes of our story that we finished up last week, Pegasus the Flying Horse. Here is Pegasus the Flying Horse, this square of 4 stars with a few trailing bits everywhere. We're going to be watching the sky this evening around 7:35 or so, because that is when the International Space Station is going to go over. I saw it once already this evening. It went over just after 6 o'clock. Nice and bright. We're going to see it go over about 7:35 or so. It'll start rising out of the west, and it's actually going to go right past the square of Pegasus. We'll try and note that for you. It'll show up here on our simulated screen as well, but if you want to run outside and be ready for that to catch the space station, that's a good thing to watch. Off in the east, well, there's the moon rising. And when the moon is up, it's kind of hard to see pretty much anything else. The moon is just too bright to, especially when it's full. All of these stars in the background are probably lost. You might only see a few of them. So we're pretty much going to ignore the east right now, because those constellations are really hard to see. If we go off to the south, though, this is where we're looking into the bright winter constellation of Orion the Hunter. Orion's over here. We're going to be talking about Orion a little bit later on in the show. If we stretch up just a little bit, there's Mars. The red planet Mars is still up there high in the south. It's gotten quite a bit fainter than it was back in its peak, but it's still up there, and you can watch for it. The planet Uranus is actually just down and below it over here. We talked about that last week as well. Okay, so those are our evening constellations. We will be featuring Orion a little bit later in the show. And what I'd like to do now is we are going to continue on with one of the activities that we started last week, which is our scale model of the solar system. Now, we did get some feedback on this from folks. Some people thought it was really cool, and other people thought it was aimed more at younger kids. We do have that issue. Of course, we're trying to cover the whole universe, and we're trying to cover programs that are applicable for everybody. We're all, at home right now, and trying to do what we can to stay safe at home. So we're trying to cover, as many bases as we can. So try and if there's something that you really don't like, do let us know. But we will sometimes have some things aimed at younger kids or some things aimed at adults or whatever. So not everything will fit for everybody, but we'll do our best. Okay, if you recall, our scale model of the solar system is based on a sheet that is available on the Manitoba Museum's webpage, and the link there. Oops. Those are our emails. That's the wrong link. Mike will put our website into the chat. The scale model is based on that, so you can make all of these, size shapes that you can put together to make the planets. You can use clay, you can use all sorts of things. I actually sort of went on Amazon, and you can buy one too. Here's the planet Uranus with its ring, and it's all sideways. Here's Venus in scale. Trying to show these without getting my head in the way. So these are all done 1 billion times smaller than the real thing. So you can have your scale of the solar system. Here is Pluto on this side, tiny little thing, and Eris, another one of the things in the outer solar system. You can probably barely see them. They're really, really small. So once you put these things together, you wind up with, a fairly impressive set of models that you can have on your mantle. Here's Jupiter with the ring. It's almost the size of my head. Some of its moons down here, their moons are, much smaller than Jupiter, but still kind of visible. And so you have all of these pieces. But the key thing of a scale model is not just the sizes, but also the distances between. We can't demonstrate that to you here because for this scale, the planets need to be hundreds of meters, thousands of meters apart. So that's something that you sort of have to do yourself. In order to talk a little bit about what that looks like and how it works, we are going to be bringing on one of our guests here. Our good friend, Megan Waters, who is a teacher here in Winnipeg. She has done a number of programs where she has been working with the scale model of the solar system, and she's done a wonderful job of it. So I'm trying to just bring her up to, there we go. I think, Megan, you should be able to turn on your video and your audio, and now I just need to pin you up here. There we go. Can we hear you?
Can you hear me?
Yes, I can hear you. Can you hear me?
I can. Well, that's really good.
A good start. Yes, excellent. Okay, I'm going to just make sure that you are spotlit for everyone so that you can be easily seen. There we go. Okay, so Megan, tell us a little bit about how you started your scale model of the solar system and what sort of kicked it off for you.
Yeah, so I was talking to my husband, who is a huge space nerd. He's all into science fiction. And one of the things that he wanted me to convey to my students was the vastness of space. And one of the things we see in books when we talk about space is, should you make the orbits to scale on a piece of paper, the size of the planets would be microscopic. So what we did was the students did a lot of research on the distance of each planet from the sun and how big they were, so their diameter. And then we just scaled it down so that Neptune would be 4.3 kilometers from the sun. And we chose that distance because that's the distance from La Gimadière at Fermor to Glenlawn Collegiate. And then we basically scaled everything down from that point. And we ended up with Mercury that was 4.6 millimeters across. And basically, we had the students drop them off at Lage at Fermor. And we put our sun there that was 1.3 meters across. And we basically walked it. Well, you came with us. It was pretty fun. And it really, really showed the students how small Mercury was compared to the sun. But also we had to walk like 56 meters before we put that down. And then again, 100 meters before we put down the next planet, and so on and so forth. And the last planet, we walked all the way to Glenlawn Collegiate. So it was quite a walk. And it really showed the students how much space there was between these planets.
Yeah, and it was, if I recall, it was quite cold and windy.
It was, yeah, it was, I think we did it in the fall or spring. It wasn't like the dead winter. I think it was like March-ish. Yeah, so it was windy.
I definitely recommend this as a spring activity for sure.
Yes, definitely. So
yeah,
I think. Sorry, go on.
I was going to say, what do you think the students were most impressed by seeing this whole everything in perfect scale?
Well, I think it was just, it was a very physical activity. And for a lot of students, you know, science is something that's done in class and with books and things. And they don't really get a lot of chance to do things really hands-on like that. It requires a lot of planning and so on and so forth. But I think they really got the idea that the orbits are quite big, and it's almost every next planet is almost the double of the one before. So take what you walked and then almost double that, and then that's where the next planet's going to be. So, and of course we went up to Neptune, but we didn't include any of the exoplanets. And I told them it would be all the way at Confusion Corner if we were to keep walking before we saw another, like, you know, object that was, you know, of note. And I think it just really conveyed to them, you know, Jupiter was the size of like a grapefruit. It wasn't that big, but you couldn't see Lage at Fermor from Jupiter or Neptune. Like, we were getting really, really far. So yeah, I think it was just a really visual way for them and physical way to really understand the solar system.
Yeah, absolutely. I think that's something that that doesn't get done necessarily enough, is the idea of, you know, science being part of the world around us and something you go out and explore and walk around and do, as opposed to just sort of learning facts. So I really like that that approach. I know my daughter, who was in your class at the time, quite enjoyed it, and we still talk about those the hike to Neptune, as I recall. Actually, it was the hike to Uranus, I think, is the joke that comes back.
Fair enough. Yeah, we're hoping to eventually get it to be permanent so that people that are walking and cycling can get a feeling. And it was by complete accident that we happened to be walking around the speed of light. You know, that was a happy mistake or happy accident, and it just really worked that way, that it was like almost like a 4D experience, because our experience of walking would have been the same amount of time it would have taken for the sunlight to reach those planets. So that was just like a funny little thing that we didn't plan.
Perfect. Yeah. Well, it was a great activity, and thank you very much for coming on and telling us about it.
My pleasure.
Okay, we'll talk to you again. Thanks. Okay. So if you are a teacher, feel free to use this in your activity. If you are not a teacher, feel free to pass this on to your class, because it is the kind of thing that, you know, I'd love to say, oh, well, just come to the planetarium and we'll do everything for you. But of course, this is something, we don't have a 4.3 kilometer place that we can walk in our facility either. So this is something you really need to do on your own. And it really does give you a sense of the vastness of space. I mean, it's like when you go outside and look up at the stars, and you just see this infinite sky. So many, oops, that was weird. This with so many pieces of starlight up there, that it really gives you a sense of the infinite. All right, we are going to move on to a new set, or a segment that we like to call cool space stuff.
Cool space stuff.
That's our very own Mike there on the vocals. It's nice to have you go.
Sorry, I'm still laughing at hearing my own voice.
I know it's one of those things, hey. So we're starting cool space stuff this time around with something a little somber. Today is NASA's Day of Remembrance, to remember all of the folks that gave their lives in the exploration of space. This is actually sort of a really bad time for NASA in terms of the time of the year. They've had 3 major accidents. All 3 of them basically happened the end of January, beginning of February, between the 27th of January and February the 1st. So it's just, you would think that they just wouldn't do anything that week anymore, but it has become sort of the remembrance. And it just reminds us that, it's cool to think about going to Mars or doing all these things, but space exploration is still a dangerous kind of thing. It does have some risks to it, and we're working to make it as safe as possible and things like that, and lots of great things are happening, but there is still a price to be paid sometimes. So one of the other things that we will be talking about in cool space stuff here is sort of where we're going right now. The International Space Station is going to be coming over in about 4.5 minutes. It is a football field sized spacecraft. It's got about as much space inside as a couple of school buses put together. So imagine living for 6 months in a couple of school buses with 6 of your favorite friends. And it goes around the Earth every 90 minutes or so. It's got these big shiny solar panels here that collect energy and give it all the electricity. And those are also very reflective. So when it's dark down here on the ground, the space station up there at 400 kilometers can still be in the sunlight. And so what we'll see is the space station lit up by the sun as it moves around. So it looks like a really bright moving star that moves from one side of the sky and moves across and disappears. It's got a very steady white light, and it's really kind of magical to watch as you see it go over. It doesn't go over at the same time of night every night. It is usually visible for a week or so, then we can't see it for a couple of weeks, then it becomes visible in the morning sky for a week or so. There's this sort of cycle to it. But right now, and for the next week or so, you will be able to see it in the early evening. So it's the best time to go out and see the space station. And remember, there's people living on it. That little dot that we're going to see go over has 7 people living on it full time, which I think is just amazing. The idea that there's, we have humans living in space already. So that will be coming over very, very soon. What we're going to do here is I'm going to switch us over to Stellarium. We're going to get us to the appropriate spot. If you have the opportunity to actually go outside, look towards the western part of the sky. So if you look where the sun went down, off towards the west, the square of Pegasus is over there. And what we're going to be looking for is we're going to see the International Space Station sort of come up from the western horizon and move almost straight up in the sky. Now, it won't go all the way across the sky. It'll go up into the sky and then it'll disappear. The Earth's shadow will actually sort of get in the way. And so what happens is the space station will go up there and then it'll basically have sunset and it'll still be there. We just won't see it because there's no sun shining on it. So we'll see it for a couple minutes. It'll move up there and it'll disappear into the Earth's shadow. We can actually predict these things. And oh, there's the crew. Those are the folks that are living on it right now, all 7 from 3 different countries. This sheet is available on our website, and it has all the information to tell you exactly where to look, what time to go out, and what time, what direction to look, and so on. So you can download this, and it's a PDF. If you print it out, you can just use it. There's descriptions underneath of what all these numbers mean. But if you use the PDF, you can click on the little, blue dates there, and it'll actually wind up giving you a chart like this. This chart is an all sky chart. It basically represents the entire sky all the way around. So you've got the horizon all the way around here. The zenith, the point straight overhead, is right in the center of the map. So this is like the planetarium dome squished flat onto a piece of paper. Let's just zoom in a little bit here. The way you use a map like this is you face in a direction and then rotate it so that direction is at the bottom. So here's your horizon. Here is where the view that we were showing. There's Pegasus again. There's Cygnus the Swan. There's Mars over there. And the space station will come moving up here. So that's basically what we're looking for. It should be rising above the horizon already. But the thing is, as it comes towards us, it's actually, when it's down low in the sky here, it's actually quite difficult to see because we're looking through all of the Earth's atmosphere, and it's actually quite far away when it's over the horizon, and it'll slowly come higher. But it's not really just moving higher, it's moving mostly towards us, kind of like an airplane that's just taken off. Once it gets up maybe about here though, it'll be nice and easy to see, and then it'll start moving quite quickly. So we should be able to see that coming over almost any time now. And so if you have the chance to, oh, here, I think we're starting to see it rise above the tree there. Now this of course is a simulated view, but it's using the orbit of the space station. And this is pretty much what it'll look like. It looks like a really, really bright star outshining everything else, slowly moving in the sky. So if you're outside now, try and take a picture or just say something in the chat. That's the space station going over right now. And we can see it every night for the next week or so, sometime in the early evening. So it'll be a good thing to watch for. I'm going to move the sky a little bit here, just so we can sort of see where things are. Up at the top of our screen, there's the W shape of Cassiopeia. It's basically heading straight towards Cassiopeia, but it'll fade out before it gets there. So that's basically the area of the sky to look for. By now, it should be so bright that you can't mistake it for anything else. And it is moving quite rapidly, so it's quite easy to see. I wish I was not sitting in a basement with no windows looking at a simulated screen, but was outside with you folks actually able to see it. So for those of you that are outside, we'll let you watch that. For those of you that are inside with me, we're going to move on to a few other things. Let us get back to our PowerPoint. Sorry, don't like to use the name, but let's get back to our images here. We like to feature one constellation every week. There are 88 official constellations. They can take some time and some practice to find. Most of them don't look like what they're named after. Some of them are ridiculous, like 2 stars that are supposed to be an anything. A lot of them were named in honor of instead of because they looked like something. But in the wintertime, Orion the Hunter sort of beats all those expectations. Orion the Hunter really looks like what it's named after. It's made out of nice bright stars. It's got the famous belt of Orion, which is 3 stars in the shape of a line, basically. You won't find 3 stars that close together, that bright, anywhere else in the sky. So it really is a distinctive kind of constellation. If you're still outside from watching the space station, come on over to look towards the southeast, and you will see Orion the Hunter. I'm just going to bring it into the center of our screen here. We'll do a little zoom in. So the stars that are most obvious, the 3 stars of the belt here, 2 stars in the upper shoulders. This is one shoulder here. This is another shoulder, big broad shoulders. His head is not all that bright though. So that may say something about, brain versus brawn. These 2 stars down here will be his legs. And then hanging from his belt is a sword. And out in front, he's got a shield here and a club up over his head. it kind of looks like a person. Even if we take away the image there, you can kind of see a humanoid figure in there. And the stars being nice and bright really, really helps. Orion's probably my favorite constellation. Whenever I see him starting to appear in the fall sky in the morning, I start to, it's like greeting an old friend, because you just get to know that shape. Orion is one of the oldest constellations. Many cultures have, named Orion as something. For example, to some of the Anishinaabe people, he is Nanabush. To other First Nations people, he is Winterbringer, which is an appropriate moniker for a constellation that shows up just as it's getting cold. Orion comes from Greek mythology. There's actually so many conflicting stories about this particular constellation that it's pretty clear that it's an amalgam of many stories that were put together. But almost every culture sees Orion as a person. In a lot of cases, other cultures will take some stars from other constellations and do different things with them, but almost everybody around the world sees Orion as a person. So go outside and get to know Orion. He's actually a pretty good guy. This star here, we talked briefly about it, I think, last week. This is the star in his right shoulder. This star is called Betelgeuse, or Betelgeuse, if you pronounce it properly in Arabic, but everybody calls it Betelgeuse. And that sparked a few questions on, well, where does that name come from? I told you last week that it meant the hairy armpit of the giant in Arabic. Apparently that is a mistranslation. That is not the actual name. It is the something to do with his arm, but apparently it has nothing to do with his armpit being hairy or not. Anyway, so I apologize for that. But Betelgeuse is an Arabic name. And similarly, the star down here, this is Rigel. That's another bright star. Rigel means the knee. And so again, it relates to where that star is found in the constellation. But who decided on these names? Well, in many cases, these names were chosen, 1,000 years ago, 2,000 years ago in some cases, and they have just stuck by tradition. In most cases, they are either Arabic or Greek names that were given by some of the people that made the first star maps. Essentially, if you were the first person to start writing this stuff down, you got to make the rules. Since then, though, more things have been discovered. Of course, the planets, they're not like the stars. They all move around, but the planets were all given names from Greek or Roman gods and goddesses. It was decided since they were very important, they must be related to the gods and goddesses. What about other things that get discovered, though? For example, the asteroids. We know that there's the asteroid belt between Mars and Jupiter. Most of the big ones that were discovered first were also given names from mythology. You have Ceres, and you have Vesta, and you have Pallas, and these are all sort of minor characters from mythology. Maybe they're demigods or heroes or people from, again, Greek or Roman mythology. But then we started discovering way too many things to do that. There are so many asteroids that there's no possible way you could use mythological names for all of them. And so eventually, astronomers around the world, the International Astronomical Union, that's a real thing, they decided, okay, the discoverer, whoever discovers a new asteroid, they can propose a name. And as long as that name isn't stupid or mean or something like that, or, a commercial for a company or something like that, we'll accept it. And so people started naming them after their significant others or their cats. There are asteroids named for all four of the Beatles. There's Ringo and John and Paul and that other guy. Just kidding. There's asteroids named for scientists, musicians, nobodies. There are asteroids named for people that the discoverer just happened to know. There's an asteroid named for me because I happen to know a guy that discovers asteroids and he was running out of names, and so my name came up. So there are so many asteroids. Those things are real. You can actually find asteroid Scott Young if you want to. But I didn't do that. It's not like I could just say, oh, I want to name it Scott Young. It went through the International Astronomical Union and it was all sort of officially done. The stars, there are so many stars, most of them don't even get names. They just get serial numbers because there's so many of them. It's only the really, really bright ones that get official names. And so because of that, like here, for example, we have, let's see if I can bring that up. Here we have a star which is called GSAT0206 PRNE30. Well, that was a satellite actually. Still, regardless. HIP 27511. Not romantic names at all. There are a few places that will name stars for you. You've probably seen these kinds of things. You can have a star named after someone. Those aren't official programs. They are sort of like sometimes they're a charity or sometimes they're just a nice sort of package or whatever, but the astronomers of the world are not going to come and, use the name that you give. However, it's still a nice thing to do. And it's a nice way to sort of, remember people, or to have a star that you and your loved ones can all look at the same time, even though you're separated by, thousands of kilometers here on the Earth. I had a star with a girlfriend that we could both look at from opposite sides of the country for a while. So that's kind of a nice kind of thing to do. The museum does do that kind of program. We're very clear that this is not an official kind of program, but it's a nice way to, allow that, that connection with the sky. And that's really what it's all about. We're trying to promote a connection with the sky. If you have a star that you sort of adopt, then good for you. If it draws you out and gets you to look at the sky, that's fantastic. And so if you're interested in that, of course, you should visit the Manitoba Museum's website. We've got all the details on there. You can check that out. But things like Betelgeuse, things like Rigel, most of those names, they come from a very, very long time ago. And they aren't going to be changing anytime soon. It was a long, rambling way to answer those couple of questions that came in. I probably can't do all the questions with such long answers, but we do love getting questions. We do love getting all that kind of stuff coming in. People are asking questions in the chat there. Mike, you got any questions you want to get into right now? Anything that you want to talk about?
Yeah, first of all, I just want to say, there's a couple people here in the Zoom chat that have seen the space station, but I have to say the Facebook chat is alive with the number of people who spotted the space station when it traveled overhead. So it was really exciting to see that happening there. I think actually two good questions I'd like you to cover, Scott. Joel just asked the question here on Zoom about where is Orion's Nebula located in that constellation. Maybe if you can quickly put that back up there and
excellent question. Out. I was in fact going to take a look at that, and then I got sidetracked on my names. So Orion has oops, I'll take off our links there. There we go. Orion has his belt of 3 stars and a sword that goes down below the belt. So here's your picture of what Orion is supposed to look like. His sword is made up of 3 stars, and the very middle one looks a little bit fuzzy. That is because that is not just a star, that is the Orion Nebula. A nebula is an old, I think it's Latin for little cloud. And so it looks like a little cloud in the sky. It doesn't just look like a dot. As we get closer though, we see that it is a huge cloud of hydrogen gas. And hydrogen is what you make stars out of. So basically this huge cloud of hydrogen gas is swirling around, and down in the very center where it's densest, gravity is squishing it together and making baby stars. This is a stellar nursery churning out baby stars as we watch. Now, as we watch, well, it takes tens of thousands of years for a star to turn on from, a cloud of gas to an actual star. So you're not going to go out there and see a big flash or anything like that. But scientists can study this, and by analyzing the starlight, by tracking the stars that are inside and how they move around, by seeing how they change in brightness, we can learn about how stars are born, which is great because our star, the sun, is 4.5 billion years old, and nobody was around when it was a baby. So we learn all about the nighttime, all about, stars as babies by looking at other examples. So the Orion Nebula, perfect example there.
Also, probably, Scott, a good segue to mention that I believe that's our topic for next week's episode. Is that not correct? The lives of stars?
Right.
Yeah.
That's right. Next week, we will tour the winter sky, and we will see examples from star birth to infant stars. We'll see teenager stars. We'll see them move away from home. We'll see them become adults. We'll see them become senior citizens, and we'll be with them all the way through the end of their life. So we'll see the whole thing just by looking at stars we can see with the unaided eye. So that'll be our topic for episode 5, which is next week.
Fantastic. Yeah. We're running a little short on time here. We had a lot of stuff into tonight's episode. It's been amazing. But there is one more question that I thought really important for everybody to know. Kathy in the Zoom chat was asking, are there constellations in the north and east skies? You focus a lot on the ones in the south and west. And I sort of answered it a little bit, but I thought you'd want to explain to our audience a little bit about why you're focusing in those areas.
Yeah, sure. That's a great question. Well, the north, there are constellations there, but there's only a few bright ones, and they don't change very much. It's not like there are different seasons for the north, because if you remember, we have the Big Dipper and we have the North Star, and they just sort of circle around the North Pole. So the Big Dipper, if it's here in the spring or in the winter, and it's over here in the summer, but it's still the Big Dipper. And the stuff that's on this side moves over to this side in the next season. So really, it kind of stays the same. So we don't talk too much about the north, other than that. The west, we talk about those constellations largely because they're disappearing. As if you've been watching the show since the beginning, constellations like Pegasus and Cygnus have been getting lower and lower right after sunset, and eventually they're going to disappear entirely. So the ones in the west, those are kind of the only one. This is like our last chance to see them before they disappear for the season. The south, well, the south is pretty much the best time to see constellations. Because of the way things move, things will rise in the east, go up into the sky in the south, and then set over in the west. So they're actually at their highest when they're in the south. So that's kind of the prime time to see pretty much most of the constellations. So we try and focus on them there. The ones in the east, well, right now the moon is in the east, and so it kind of interferes with our view, but that's not the main reason. The ones in the east are going to get better as the year goes on. For example, we've got, this is Cancer the crab that the moon is in right now. And then over here we have Leo the lion, another constellation that, is quite famous, but it's low down in the sky right now. Give it a month though, and it'll be up higher and we'll be able to see it. So we have kind of been focusing on, the west and the south, because those are the ones that are either disappearing or they're at their best. So if you happen to be in a place where you have, say, an east-facing window and that's all you can see, go to our website, download the star maps, because what I've done for our star maps is we've basically printed out one for each direction. And so instead of that big complicated round map that you have to move around, there's basically an east map, a west map, all those kinds of things. And it'll allow you to see what is facing, your window or the way your balcony faces or whatever direction you have a good view of. So that'll help you find those constellations. And you can download those through our website, which is ManitobaMuseum.Ca, and then click on the Dome at Home picture on the top, and that'll take you there. All of our resources are there: star charts and the scale model of the solar system and the space station sightings. All that stuff is all there. So it's a good place to get your resources.
All right, Scott, I got one more question that I promised Audrey from the beginning of the show that you would take a look at it. Hopefully you can quickly do. I just put it in the chat. She's asking why do not more astronomers use the HA-ray system of joining the dots on constellations? And so if you can quickly touch on that, because I did promise you would do that.
So HA-ray is, he wrote Curious George, but he also wrote a star book called, I forget. but he redrew the constellation line figures so that they kind of worked and looked like the pictures. For me, I find that if you live in a place where the sky is quite dark and you can see all the faintest stars, his patterns kind of work, but he doesn't really distinguish as much between bright stars and faint stars when drawing those pictures. So you need to be able to see all of them. And so from inside the city, I find that some of his pictures don't work quite as well. Having said that, from inside the city, some of the constellations don't look very good anyway. So maybe it's not a big difference. We can in fact set this program to use the HA ray constellations. So I'll make a note to try that next week, and we'll see if they look any different, see if that makes it a little bit easier for you. So that's a good question. Okay, so many questions. Oh, lots of people saying they saw the ISS. That's great. We've got, oh man, it's so nice to see all these questions. We are unfortunately running out of time. I do want to thank Megan Waters for dropping by and telling us about her scale model of the solar system. And we will be back next Thursday at 7 o'clock. We will be looking at, again, some winter constellations. I think we've got Taurus the Bull up, and I think we've got some of the, as Mike mentioned, we're going to be looking at the life cycles of stars. We'll also be able to start, I'll have some images of the moon by then, hopefully. I'm thinking I might head outside tonight in the frigid cold and try and get some nice pictures of the moon. If you want to stay in touch, definitely join us next week. You can register for Zoom, and that way you're in on the chat. You can also watch us through YouTube, Facebook, and if you have questions or you have pictures you want to send us, you can always send them to space@ManitobaMuseum.Ca. So thank you all for attending. Thank you very much to the Province of Manitoba Safe at Home grant, which has made this program possible. And thanks to all of our folks at the Manitoba Museum for supporting the program. Thanks, Mike. You have a good evening. I hope you get to see the moon and a few stars tonight as well.
You bet. Have a good night, Scott.
Okay, you too. Thank you, everyone. It's great to see you all, and we will talk again soon.